So here's a scenario. Okay, you're the network engineer, Zamir. He's a junior network engineer, and I'm your customer, right? And I have, an executive, very important person, right? He has PC1. He is unable to get an IP address from the DHCP server. Okay. I want you to tell me how can we configure our network to make sure that this PC can get an IP address from the DHCP server, and also educate me and let me know how that packet will travel through the network on each hop, meaning each device. Okay,
so,
how that packet's gonna look.
Okay, so I just need to make sure I got exactly what you said. Okay, PC1. So I know you told me I need to tell you PC1 is going from. Could you tell me the other PC one more time?
Yeah.
Oh,
PC1.
the DHCP server. I'm sorry, it was a lot. I was trying to fix my Zoom and stuff. Okay, so it's going from the DHCP server, and you need me to tell you how it's doing that hop to hop. So I know you're telling me about each interface, how it's reading the MAC address.
Yep.
And then you also need me. What was the first thing you need me to tell you? I know that part.
Yeah. No, it's cool. It's all good. So tell me what we can do to make sure that PC1 gets an IP address, and I need you to show me how that packet is going to look on each hop, meaning each device. Hold on, let me get a little pencil.
No, I know what you mean from yeah. Let's see.
Yeah. So how is it
from
gonna look at each hop? So what I'm gonna do, like you see here, I have my little table, So at each hop, I want you to tell me what the source MAC will be, the destination MAC will be, source IP and destination IP. And the thing that I do with people, and I'm sure you saw in the CCNA question of the day, I'm gonna ask you why. Okay? I'm always gonna ask you why of why something is the case. My goal is I want you and everybody to be a great engineer. I don't want you to be just somebody who can just press buttons and look at stuff and be like, oh, it's like this because of this. You're an engineer. You're not just another computer. Okay.
Okay.
So, cool. So PC1 plugged it into the network. My CEO, and I want to go ahead and get an IP address. How is the packet going to look from PC1 onto the network? What'll be the source MAC?
The source MAC for PC1. Make sure I can see it. Oh, it's ZZ. My bad. I'm trying to do it on my phone.
It's all good. ZZ.
So
okay.
The MAC address is ZZ. The destination MAC address. In order to get to the DHCP server, I'm assuming the next one is gonna be. Let me make it a little bit bigger. I would say it's gonna go to the router, which is it's HH. I didn't see where it was. That's why I'm like, I see the router. Okay, so I'm thinking it's gonna go to HH next.
Why is it gonna go to HH?
Oh, well, I'm thinking it's going to HH next because it's the hops and it's the layer 2, and what it has to do is, in order for it to go to DHCP, it has to still go out of its network, and that's the router that's going, the gateway to take it out.
Good.
To take the data out or to pack it out, the request.
Okay. So let me ask you this, right?
Yes.
Let's say all the router has is just an IP address. It doesn't have nothing else configured. How is the packet from PC1 going to know how to get to the DHCP server?
If it only has
no IP.
Oh, if
it doesn't have no
has
IP setting.
Address?
It doesn't have an IP address.
You're saying it doesn't?
Mm-hmm. PC1 doesn't have an IP address. How is it going to know to get out? How to get to the DHCP server if it doesn't have an IP address? What can we configure within this network, this small network right here, to make sure that PC1 can reach the DHCP server?
Oh, there we go. I'm sorry. It was jumping me off the screen. to like a safe
Oh, it's
drive.
all good.
No, but
It's
how
all
would
good.
I?
It's all
Okay,
good.
so I'm gonna tell you the truth. I'm not sure that I would know the answer to that. If you're saying that PC1 only has an IP address, and how would it know how to get? Oh, well, it would use the source IP address for the DHCP server, perhaps.
Not close. Close. It would use the IP address of a DHCP server, but where I'm getting to, right, is I'm sure you saw it in your Network Plus, right? It's called, it's going to use an IP helper address. Okay, that's going to be configured on R1. Okay, and what that does is that IP helper address, it responds to any DHCP discover messages, right? Basically, messages, that first packet from PC1 that's saying, hey, where is my DHCP server? Okay, and so we see, right? R1, it's not on the same network as a DHCP server. So if we don't know about it, if PC1 has no way of knowing about it, that package is going to be dropped by the router, right? Because it's a broadcast that PC1 sends out throughout the network saying, hey, who's the DHCP server, right? And broadcasts stop right at the layer 3 boundary, which is that router. But, right, if we have the IP helper configured, right, which will be the IP helper address is going to be the address of the DHCP server, okay? So it's going to have 10.0.0.15, okay? So with that being said, what's going to happen, right, is PC1 is going to go ahead and send that message. It's going to send a message to what we call an ARP. I'm sure you've heard about it before, Address Resolution Protocol.
Yeah.
Yep. It's going to send that message and saying who has 10.0.0.15. And R1 is going to respond, and this is the smart thing about IP helper and DHCP relay is it's going to say, hey, I know who the DHCP server is. I know you don't have a IP address. I'm going to go ahead and forward your request for you, okay? Because what can't happen, right, Zamir, is we can't go ahead and forward a packet that has an IP address of 0.0.0.0 to the DHCP server, right? Because if it can get there, but it has no way of coming back because it doesn't know how to get back. It doesn't know who has 0.0. It's going to be dropped.
Right. That makes sense.
Okay. So what R1 is going to do, we're going to get there. But now that you know all of this, now tell me how the packet's going to look like from PC1 going to R1.
So from PC1 going to R1. Okay, so based on the IP address it has now, like the 00 or just?
Yep.
Oh, okay. So it should be the source. It should be ZZ. Oh, you said going to R1 though. And the MAC address should be, the destination MAC should be HH because we're going to R1. The source
IP.
The source IP is 0.0.0. .0 one more time, and then the destination IP is going to be, I'm assuming what we just talked about, the helper IP, which would be the DHCP IP address, which would be 10.0.0.15.
Nice. Good. Okay. So this is the first packet, right? So we got this there. Go ahead and make a copy of this. All right. Cool. So we're right here, right at the router. So now the router got it. It's going to go ahead and do its DHCP relay information, relay function. It's going to go ahead and relay that packet onto the next network. Now, what's the packet going to look like now? Coming from R1 going to R2.
R2 to this interface. The packet is going to look like the source MAC is going to be HH. The destination is going to be GG.
Okay.
The source IP of R1 is going to be 6.26.88. Well, no, that puts it on the same one as R2 because that's the same one as that. So let's go with the other. I'm sorry, 192.168 .1.252.
Okay, stop. Let's stop here. What made you change your mind about the source IP? You're right, by the way. But what made you change your mind?
I'm gonna tell you what. So I'm doing on my phone, it's a little smaller, but when I actually look down, I realized. So I didn't know if this router, well, that would be a switch anyway, or some routers too with different interfaces. So I was looking at it and I realized they were on the same network because they were the same IP address. So I'm like, oh, that's not from. I was thinking maybe it's a different interface on the right side of R1, but it wasn't because I looked at it. So I was like, okay, no, that's not it because they're not on the same network. They're two different routers. Yeah.
Okay, so 6.6 is on a different network than what?
Oh, I'm sorry. So 6.26. Oh, what I'm saying when I looked initially at R1, the way I knew that other one was because the one to the right of R1 and the one to the left of R2 are pretty much the same, on the same network. So that's why I was saying they couldn't be on the same network, being two different routers. They represent two networks, so I knew it was the one on the left of the R1.
Good. That's close to it, right? But let me challenge you. Why didn't we make the source IP 0.0.0.0?
The source IP.
Why didn't we make it the IP the source? Why did we make the source IP the IP address of PC1?
I would say because it has to come back through that router. I mean, that router knows that. I'm not really sure. Now I'm thinking. I mean, we're going out to DHCP in order to get an IP address, right? So if it goes if the source is 0.0.0, like we said already, it's gonna be dropped by the router. You're not gonna know where that goes.
Damn, you hit it right on the money. It's not gonna have a way to get back. So a little more information on it, right? So what DHCP relay does, the technology that it does, and what it does is it does something what we call packet rewrite. It rewrites the packet, the initial packet, right? The DHCP discover packet from PC1, and it says, all right, perfect. I want, here's the source IP, 192.168.1.252, but, right, the true client, right, the true person, the true PC that's asking for this is truly the MAC address of ZZ. When it leaves here, it's going to have the IP address of this, so it knows how to get back to, like you just said, this network. If we only put it to 6.26.88.1, it's going to stop here. It's not going to get back to PC1. Okay, and then we'll look deeper into. I'll go deeper into later on, not now. Later on into how that DHCP packet looks from a PC that doesn't have an IP address. But you're right on the money. So good stuff. So what's that destination IP gonna look like?
So destination IP is going to be 10.0.0.15. Is it the?
So it wouldn't.
IP
it wouldn't be.
Oh, wait. I was going to say the destination shouldn't change, right? Because the routers going to each other is just communicating. Oh, that is layer 3. That's not. I'm thinking about a switch. Okay. So I'm gonna have to go with the next IP address from the next router, which would be the 6.26.88.2.
Is that your? I mean, why do you believe so? I mean, talk me through it. Talk me with what's going through in your mind.
So in my mind,
you're on the right track.
Okay, in my mind, it's telling me that the IP address should never change. Maybe the MAC address, but I'm thinking I may be incorrect because I'm thinking the destination port and the source, should never really change. As far as the IP is concerned.
So you had me hyped. Zamir, you said it, but we just got to reverse it. Okay.
All right.
At layer 2, the MAC address from hop to hop will always change.
Right.
The source and destination IP will never change. This of course is an exception, but the source and destination IP will never change within a packet in most cases.
Right. So I was going to look at it, but I went back. I should have stayed. I'm like, no, that shouldn't change. So okay.
Yeah, so you're right. I was challenging you because I want to make sure that you understood. Okay, do I really know this or am I guessing? Okay, I don't want you to guess, but it's all good. You did good. So now, right? Now we went ahead and we see how it's going to get, over to R2. We get it to R2, okay? We get it to R2, and we're going to take a break from layer 3. We're going to go down to layer 2, okay? We have this thing, of course, you've heard of it. There's this protocol called spanning tree, right? What it does is it's one of the 3 major functions of a switch, right? And it's meant to prevent loops, forwarding loops on redundant links within a topology, okay?
Right.
You see, we have a lot of connections between a lot of switches. What I want you to do, take a break from that. We know what our packet looks like. We're good. We know how that gets there. I want you to tell me, and I'm going to help you. I'm going to walk you through it. I want you to tell me, you could take your time to write this down, what the root bridge is, okay, who the root bridge is, throughout this entire network. And then for every segment, we're going to go ahead and lay out who's the designated switch and who's the non-designated switch, okay? I don't care if you don't know it. It's okay. We're going to get to it, right? If you want to handle that in another session, we can. But I want you to at least try. Look at your notes for spanning tree and at least try to identify who the root is. Okay?
Right. So give me about 1 minute. I mean 60 to 90 seconds. Let me refresh myself on spanning tree.
Take your time. Take your time. And that page that I sent you, it should help as well. So take your time. Just call me whenever you're ready.
All right. All right, David. I've looked over a little bit. I don't keep you waiting too long.
Okay. No, hey man, hey, this time is for you, man. You never keep me waiting. It's all good. What's up?
Okay, so we were saying root bridge, right?
Yep. Who's the root bridge?
Thinking should be from what I was reading is the switch with the lowest MAC address, or I guess it was saying without having the one that I guess it wouldn't have to go through or anything, be elected the root bridge. So I'm thinking it would be DD. Or excuse me, maybe EE.
Cool. All right. So the root is DD.
I'm honestly not sure. I was saying I wasn't sure between DD or EE.
It's okay. It's all right. So let me go ahead. Hold on. I'm gonna send this to you. Give me 1 second. I'm gonna drop this in the Slack chat so you can take a look at it. And I'm gonna explain to it at the same time. I just want you to save this for your resources. So
I've seen that picture. Let's see.
Whenever a switch is electing a root bridge, right? What it's going to use is it's going to go ahead and use the switch with the lowest, what they call bridge ID within Cisco terms, right? And what that is, right? The bridge ID consists of the MAC address and the system ID, right? And typically, if we're running a network, all the VLANs are the same. The system ID is typically going to be the same. So then it's going to be, okay, the lowest bridge ID is going to be determined by the MAC address, right? So whoever has the lowest MAC address, assuming that we all have the same VLAN number for all the switches, it's going to be that, okay? So with that being said, Zamir, if you look at this picture again, who is the root? Who has the lowest? The lowest value.
The lowest value I'm gonna have to go with. I want to make sure I'm not getting it right, so I'm gonna have to go with CC if it's the value I'm thinking, because I mean I know some of those had numbers and these are alphabet.
It's all good. It's all good. And numbers are part of the hexadecimal. Letters are part of the hexadecimal numbering system, so it's all good. So
yeah, unless you mean
close,
like switch, right? 5. Well, no, you didn't say switch. You said MAC address. Okay, so yeah, I'm gonna have to go with. Oh, I'm sorry. I see BB. I didn't see BB. I'm gonna have to go with BB. I told you I'm trying to use my phone. My laptop messed up, so I'm like, wait. Oh, I see BB. Yeah, the lowest. Okay, I didn't see.
It's all good. It's all good. So. It's all good. It's all good. Now, good stuff. Good stuff. So BB, right?
Right.
So and you hit right on the money for that one. So BB is our root because it has the lowest bridge ID, right? It has the lowest MAC address. Okay.
Yes.
So the next part, right? The next part is we're gonna elect our, designated switch, right? Within the topology. Now we have a lot of redundant links. Okay. So we have a link. Let me get my little thingy. Hold on. If this will work. So we have a link, a redundant network here. Go ahead and draw it for you. Oh my goodness. My niece would laugh if she saw this. And let me change the color. We have a redundant network here. Okay. We have a redundant network here. Okay. Let me erase that. Hold on.
Yes.
Okay. Okay. And then we have another network right here. Okay.
Okay.
All those segments. In this session, because I know it's going to overload you, I don't want you, we're not going to talk in too deep about spanning tree now. I want you to understand how the root bridge is elected. We'll jump into a designated, how the election process for a designated switch will happen in the next time, right? We'll go over that next time because we're gonna have a second session. So we can have that later this week. But I want you to really think about this when you look in your notes later on this week and be like, all right, let me see how the spanning tree process happens. And we have the group has a video about how the spanning tree election process as well. So assuming that the packet went up and got to the DHCP server, right?
Okay.
And now the DHCP server, it reached there and it has its request. How is the packet going to look coming back to PC1? Okay.
Okay.
From the DHCP server going to PC1, how is it going to look? First, from going from DHCP server to R2.
So you're going to SS. Oh, you said to GG is the destination MAC. Oh, I'm sorry. So the source MAC is SS.
Source MAC is SS.
Yes, the destination MAC would be GG.
Why?
Because wait, let's see. You said it could be a different network. Because that's the path is taken to go back towards. We try and get to R2, so that's the MAC address for R2. The layer 2 it being, hop the hop is, that's the next MAC address to hop to. Switch is just forward information. They don't have, MAC address on it. In this case.
Okay, cool, excellent. So, and what's the source IP going to be?
The source IP is going to be the new IP address. Do we have a way of knowing that yet or no? Or no,
nope.
I'm wrong.
Nope.
I got it. It's going to be 192.168.1.25.
That's going to be the source IP if it came from the DHCP server?
Oh, my bad. I'm sorry. Yeah. So source IP is going to be 10.0.0.15. I'm overthinking it.
It's all good. Now, what's that destination IP?
It's going to be 192.168.1.25.
Why?
Because that's the router for the PC1 network. It should be able to, get that packet back to that PC.
Perfect. Exactamundo. So you did it perfectly fine. So that was good, right? This is a good refresher. We'll dig deep in the spanning tree in our next session we have. I just wanted you to get prepped up and start having those gears turning and saying, all right, cool. Let me see how these packets work and frames work throughout the network and how they travel. Okay.
Yeah.
All right.
I got to get back into it. I needed this because I needed to see just how much I had been, forgetting. And yeah, it was a good session.
It's all good. So, Zamir, good stuff. Like I said, we'll have another session. Let me know. I'm going to leave it on you to let me know when you want to have a second session. The second session is going to be about spanning tree. So I'm gonna have you walk me through again how to convert. See how this spanning tree topology is supposed to look, and we're going to go from there. All right.
All right, that sounds good.
All right, boss. All right, man. I'll see you, and I'll post a recording shortly.
All right, and I appreciate that.
All right, man. Later.
All right, later.